Chris Anderson here, and thanks everyone for coming out and spending a little bit of your afternoon with us to learn about Couchbase Mobile and how to get started with it as a developer. My name is Chris Anderson, and I'm a co-founder of Couchbase and an Apache CouchDB committer. And at Couchbase, I lead the mobile development efforts. So I'll be showing you how to get to Hello World on iOS today. And Dale Harvey, who's with us, will show you Android. So Dale, tell us a little about yourself.
Hey everyone, I'm Dale Harvey. I joined what used to be Couch One around a year ago, and I now work for Couchbase quite a lot on the mobile side, sometimes on the server side as well. So I'm going to be going through the Hello World for Android.
So before we get into that, which is going to be a fast-paced live coding adventure, I want to do a little bit of background in case folks aren't familiar with Couchbase. So at the very core of the technology is we're powered by Apache CouchDB. So the feature set there fits really great on mobile, and that's the reason why we went down this path of getting our software to run there. So just for the new folks, I'll go over what CouchDB brings to the table. So the underlying storage engine is very robust. It has a pure append-only storage, so that every time you do anything to the database, it's appending bytes to the end of the file. What this means is that there's nothing that can happen. There's no bugs that could happen in Couch that would overwrite anything that's already been committed to disk. It makes it very easy for us to ensure consistency. And on a mobile device, this is really important because if your battery dies or the operating system kills your application, you need to be able to boot right back up and not have to do an expensive and tedious consistency check. Your users just want to be able to use the app right away. So a big part of the underlying engineering is building a storage engine that supports that. And this is all going to be very fast because we want to focus on the mobile stuff here, but I do want to give some background. So Couch uses JSON as the storage format. JSON is JavaScript object notation, and it's just a simple string-based format that can embed your basic primitive object types for most object-oriented languages. So arrays, strings, integers, true, false, null. Those simple data types it can encode. There isn't support for richer data types like datetime or serializing classes directly to JSON. So anything more than the basic primitives, you'll write something in your application that learns how to turn them to and from JSON. But JSON is very popular web format. Almost all the major web APIs are either only JSON or feature a JSON endpoint. So Couch speaks JSON as its native language. You can also store binary attachments in Couch. So there's people who are using it to deliver media files to phones, or you can even use it for your web server in the cloud. And there's a lot of folks doing that. The key feature in Couch that brings it to the mobile device for us and really makes it compelling is this replication, which in the mobile world we often call that sync. So anytime you've got a couch, you've got two couches, you can use replication to synchronize them so they'll have the same content. And I won't get into the details here, but that's another big core aspect of the Couch engineering is making sure that replication is efficient and doesn't send information it doesn't need to. So the first time you sync, it'll be it'll run over all the data on the source device. But the second time you do it, it'll only send the diffs. So this makes, or not exactly this, only send the new changes. So this makes it especially ideal for things like syncing your application data from mobile device. So maybe it's your contacts and you only need to transfer around some information when a phone number changes. You don't need to push the whole database up and down every time you need updates. So this allows you to bridge data between the cloud and your device, and it's in nearly real time. So if you have multiple devices, multiple users, they can all share a cloud endpoint, and they'll see each other's changes in real time. I won't have time in this webcast to get into some of the security model implications and some of the interesting stuff around how you would do shared data applications and how you would ensure that people are only allowed to do what you want them to do. But this this feature goes deep, and there are lots of patterns and APIs that are designed to make it so you can build secure applications that run at the edge of the network on your end user devices. So that's really why we're here today, is this sync capability. But if it was only that, it wouldn't be so easy to write apps on top of. So we also need to be able to query this, and that's where MapReduce and Geo Couch come in. So MapReduce, got its fame in these large-scale installations, things like Google and Hadoop. And Couch is certainly capable of doing that, but the real joy of MapReduce and Couch comes with, when you're dealing with messy data, which is what you often find in the real world. So rather than thinking, oh, MapReduce, this is like some new way of doing things, I find it's often easier just to think of it, if you're familiar with in the relational world, you've got your alter table add index and then some SQL definition of what that index ought to be. And so imagine taking that SQL statement and replacing it with a JavaScript function that can pull whatever it needs to out of your row. So if your rows are all different and if your rows are all different, you can have branching logic in your index that says, okay, if it looks like this, index this attribute. If it looks like that, index it this way. You can run a regex in there. So maybe you've just got a whole big mess of content, and you need to pull out some statistic. And sometimes maybe it's already cleanly stored in the document for you. Other times you might have to pull it out. But at the end of the day, you've normalized your data. So what MapReduce allows you to do is build a normalized index on top of messy real-world data. It's a really powerful feature, and you don't see it in really any other mainstream or open-source database in quite the way that Couch has it implemented. The Geo Couch is another similar feature. It allows you to search by geometries, so you can put in a bounding box and find what polygons or points that intersects. So this gives you the ability to build all these geo apps that are getting really popular on mobile devices and have the queries that you need to run right there on the device, not have to wait for latency while those queries go over the network to some server and back again. And then down at the very core, low layer for a mobile developer, it's right at the front of Couch if you're a web developer, but it's based on HTTP, which is the language of the web. So this makes it real easy to write web apps on top of. And then in the case of a mobile app, we have wrappers around HTTP. So if you'd like to go and fall down to the RESTful interface, that's available for you. But you can also use a Cocoa wrapper that will give you a very native feeling API. So this is sort of the basic overview of Couch. I don't want to dwell on this too much because I have a feeling a lot of the folks in the audience are familiar with Couch. So let's talk about mobile and why we're motivated to go into this industry with this technology. I don't want to get too businessy on you, but everyone is talking about cloud these days, and in the computing world, mobile is almost as big as cloud. But the trend is what's interesting, and what we see is that mobile is growing much faster than the cloud, and an interesting point to that is that a lot of the growth in mobile is coming from the developing world. So this is not only, it's not just taking the internet and the technologies that we're familiar with and extending them, yet another layer. It's sort of building this opportunity for new kinds of applications and new kinds of users. So this is what gets us excited about building mobile apps. And if you're here, you're probably already excited about mobile apps, so I don't need to tell you too much. So while we support iOS and Android, and that's what we're going to talk about today, I want to give a little bit of background of where we're going with this. I always like to keep my eye on the horizon. And smartphones are, that's where the action is these days. But the technology, even on distributed systems like wind farms or inventory tracking, all these systems are getting more and more powerful with Moore's Law, and this synchronization offline access is, very important when you are out there in the real world. It matters a lot less when you're sitting in your office in Silicon Valley hooked up to a T1 line. But when you're out in the real world, you don't necessarily have control over the network. So for instance, if you're a cell tower, like in the picture in the back of this slide here, normally you're connected, right? That's the whole point of being a cell tower is you're connected. But it's that time when you're not connected and you need to reestablish your connection. That's when your database needs to work. So if you've got some storage on that cell tower and it needs to be able to refer to some configuration and figure out what the fallback data path is for calls that are coming in, that service itself, it would be sort of bad if that stopped working right when you need it. So this is kind of thinking about these possibilities is what drives our imagination. And even though we're just, for now, building smartphone apps, those smartphone apps are able to reach out to sensors that are out in the real world. And, of course, as I said, smartphones are getting smaller and smaller. So eventually that same capability is going to be everywhere. One thing also that you'll want if you're out there as an application running in the world that may or may not be connected to the network is the ability to actively synchronize with other applications that are out in the world. So whether or not that's, you bump your phone with your friend and send a contact, or you're passing another car in traffic and it hands off data about road conditions up ahead. These are all possibilities that we're looking toward, and that there's very, very real development effort going toward among some of our users and customers. And the last sort of concept slide I want to show y'all is ground computing, right? This is what we call this. Cloud computing is great, but it can't do everything. There are places the cloud can't reach, and Couchbase Mobile wants to fill in those places where the cloud can't reach and offer ground computing. So I want to go through a couple of use cases real quick. These are just some folks out there using Couch that we're proud to talk about. There's a lot more like this where these came from. These aren't exactly mobile, but they do illustrate the disconnected use case and the flexibility of our synchronization. So Assay Depot is a San Diego-based company that does a product where different pharmaceutical companies can exchange jobs that need to be done. And so maybe that's run this chemical across 1,000 test tubes. And then there's other companies out there that basically just run these robots that know how to do that stuff. And so they take jobs from the researchers and run them. And as you can imagine, there's all kinds of competition in that industry. And so there's a bunch of security about who's allowed to see what. So the way these guys do it is they maintain a replica for each of their customers. And then they use a filtering mechanism through that runs inside their firewall to make sure that each replica only contains what the customer is allowed to see. And this means that they have a built-in audit trail. It's better than an audit trail because it's what you see is what you get. So if a bug were to go to production, you would know the consequences of that. It wouldn't be a question of what happened while the bug was live. You can go look in the customer's databases and potentially make corrections. So having your data, be encapsulated in a synchronization endpoint for your customers, sandbox that's just that customer's data, has been really helpful for them in terms of being able to put together a business model around this frictionless sharing of data in the industry they serve. More toward the mobile use case, Dhemaji is built a technology that runs in a network of health clinics in rural Zambia. And so these health clinics are connected to the central office via cell phone modems, but the cell phone network uptime is fairly low. Certainly, even when it is running, the latencies are too high to make it acceptable to run a web server at the central office and have web browsers out at the clinics. And so instead what they do is install Couch on the computers at the clinics, and all the activity out there is local. Whenever the cell phones are connected, it synchronizes up and back. And so this has allowed, now they don't have to drive a doctor for a day to go find out what's the state of this clinic. They can see just by looking at the computer, whether or not they're taking vital signs, things like that. This PDX API is just a tip of the iceberg here of what people are doing with Geo Couch. So there's a bunch of cities that have realized that they're sitting on a whole bunch of useful geographic data, and it's not doing anybody any good when it's just in their archives. So they started to open that up to citizens. And that's great, but it's usually in data formats that are a little bit hard to get into. So there are some activists who convert that to Geo Couch, and then they're able to put it up at an endpoint that may not be high availability, but someone else. So say you've got all the Portland data up on this Geo Couch website, but it's maintained by an activist and not a big company, and they're not charging you for access to it. So it may not be high availability, but you want to provide just the bar data or just the restaurant license data essentially as part of your application. So you can use Replication to synchronize what the activist has created with your backing, with your copy of it, and you provide the high availability version out to your mobile application, while the activist may concentrate on importing new data from the city government when it's available. So as long as you maintain that sync feed, every month when the activist updates their copy, it'll get copied over to your high availability version, and your end users will have the benefit of that new data. So this is just another way you can use synchronization. The last vertical that I want to mention is the real estate, oil and gas, mining, any kind of industry where you've really got to be on site and where you may be away from networks. You may be in northern Canada, or maybe you're the cable guy and you're going to fix the internet at somebody's house or somebody's apartment, and you get in the elevator and you forgot what floor you're trying to get to. And so are you going to go back out of the building, or do you have your data on your device and you can just run the search again? So these are just some of the use cases that we see people diving into with Couch and Couchbase Mobile. So hopefully that's enough to whet your appetite. One last thing before we get to the live coding part. So Couch has a gang sign. It's sort of like the rock and roll horns, but relaxed a little bit. And the idea is that's supposed to look like a couch. The guy up in the corner here is Damian Katz, the creator of CouchDB. And the guy in the big picture is a buddy of mine on Twitter who also did the picture and just looked good. So I'm going to pop over to iOS now and walk you through what it takes to get the Hello World on iOS. And once we're done with that, we'll have Dale take over and talk about Android. Actually, I see a few questions in here. Let me see if any of these are. I think it's actually good to do these questions before we drop into the live code.
Yeah.
So I'm going to take it from the bottom. Thomas asks, is the cloud necessary for replication? Can it be done device to device? Absolutely. So what you need in order to sync is the ability to address the two, have one endpoint reach the other via HTTP. So if you're on a LAN and you know each other's IP addresses, then you're basically done. I mean, you've got to do a little configuration via the Couch API. Now, if you're across wide area networks or both behind NATs or routers, it's going to get more challenging. And so in that case, the real simple answer is just stick an endpoint in the cloud. It's not that hard, and they can both address that. And then you've got your synchronization there as well as a cloud backup. But if you wanted to do your firewall busting, there's no reason Couch wouldn't be able to replicate over it once you establish that HTTP connection. So I hope that answers that question. Got another question here about support for HTTPS and gzip. On iOS, the product in general supports both of those. On iOS, we don't have HTTPS today, but we will have it in time for our GA release, which is in roughly a month. That's one of the outstanding features, or we hope to have it. It's kind of a challenge to get that crypto running in the embedded environment. On Android, I believe we have HTTPS support today. Is that right, Dale?
Yeah, Android supports HTTPS fully.
Yeah. So yeah, these are good questions. We're about halfway through. Another question here: what's the difference between mobile and cloud? I mean, as far as business goes, when I say mobile, I mean there's just a whole ecosystem of players. People everywhere, everyone from Qualcomm to Verizon to handset manufacturers, and cloud is really more Web 2.0 and Amazon Web Services and Salesforce, those kinds of things. So cloud, I really think is it's hot today, but we may have seen the big growth in cloud, like we may be sitting on top of that right now, and now it's sort of entrenching itself. Whereas mobile is the blue ocean, if you would. Yeah, just another note on the gzip support. It's the attachments that are gzipped, and there's actually a configuration directive. You can say which MIME types you would like to gzip, and the defaults are sensible. For the storage file on the device, at least on iOS and soon to come on Android, and as well on the server, we use Google Snappy compression for the files we write out to disk, and that just helps with our overall disk throughput because usually CPU is cheaper than disk in terms of time. So some questions about libraries and the license. First, I'll talk about the license. Everything that we're going to show you today is licensed under Apache 2.0, and as is the Apache CouchDB project. So Couchbase is an open source company, and everything we've done so far is open source. We love open source. That's what got us here today, and we think it's really important. I mean, not just to be nice guys, but it makes our jobs easier to contribute back to open source. But at the same time, if a customer has a demand and the only way to meet the demand is to license some proprietary library that we would use internally and then relicense to them, that might end up that we'd have some proprietary features in our enterprise edition. So we're not closing the door to that, but currently today everything is open source. As far as libraries, Java, PHP, Ruby, Python, all that stuff is on our couchbase.org website, and that's a great segue to this next section because I'll start off on our website. So I'm going to launch the screen share here, and you all should see my browser window. So before we jump in, I just want to remind folks that we have a conference coming up in New York City on October 24th, and I think early bird ends today or maybe later this week. Right now, registration is only $75, so it's going to be, if you want to get in deep on this stuff, it's a 2-track program, and we're going to have a bunch of the engineers and team members out there. I'll be there, and it should be a good time. So what am I going to assume for this section? I'm going to assume that you've got Xcode installed and you've used it before, but that's really it. I think that this should be pretty straightforward for anyone who's interested in iOS development. I'll try to go at a pace that you could perhaps keep up, but if I go too fast, this video here on the web page will show everything that I'm planning to do and perhaps explain it better than I'll be able to in this webcast. So if you want to get to this web page to follow along, I'll actually take you through the click path so that you don't have to type in a long URL. So if you go to couchbase.org and you scroll down below the fold, and down here we've got the mobile, and click go to iOS, that will take you to the page that I'm on here. So what you'll need to do is download the developer preview release. We have a beta release in the works going through the QA process right now, and I'm pretty sure actually that this download link points to the release artifact that is going through our QA process. If we find bugs, we may end up cutting a new artifact, but it's certainly very close to what we'll be releasing as beta next week. So I've already downloaded that, and my download file is here. Once your download is done and you open it, And that download will be coming from a content delivery network next week. Right now it's coming off of our servers, so you guys may have just slammed our servers, but thank you for that. So if you open it up, there's README, which is the same instructions that you'll find on the web page. So we'll just work from the web page. It's a little bit easier for me to work from. And then there is a folder called couchbase.framework. That's where the action is. We'll come back to that in just a second. So the next step, now that you've got your download or while you're waiting for your download to finish, is to launch Xcode. And you'll see an option to create a new Xcode project. I'm using Xcode 4.2 on Lion, but it shouldn't matter what version of Xcode you're using. I've tested this as far back as I think 3.2.3, and it works. Maybe some of the places you've got to click to get stuff done are subtly different than what you'll see on my screen now. So let's do a single view application. I think it doesn't matter. You could pick any of these. And we'll call this product name Hello Webcast. And I'll put a class prefix here, although it's not necessary. So we'll click Next, and then I'll resize my window so you can see it. I've stuck this in the screencast folder here. So Xcode's going to want to default to full screen, but I can pull that in. And so what we've got to do now is essentially just link that framework in and drop a few lines of code into our application, and we'll be to hello world. So the first thing to do is to drop the framework in. You'll want to pop open this frameworks triangle here, and then go back to the Finder and get the Couchbase framework folder. Now before you do anything else, we encourage you to put it into your project directory in a subdirectory called frameworks. So I'm going to go ahead and do that. Now this is optional. I mean, it's not going to break anything if you don't do it this way, but one of the later steps you'll have to make a slight change compared to what I do. And the reason we do this is because when you get into building real applications, you'll probably also want our Couch Cocoa framework. And so it's nice to just have them both in the same place. So now I'm going to move Couchbase.framework into here. That actually hasn't done anything in Xcode yet. It's just, now it's in the same project root as everything else, and it'll show up in our version control system and whatnot, if that's what we're interested in doing. So now that we've got this in the right place to get started from, I'm going to take this folder and drop it right there on the frameworks section and come back over to Xcode. And these defaults are correct, so we click Finish. Normally what happens next is I forget what I'm supposed to do, which is good because that means I can show you the instructions. So here we are. We need to link some libraries with our project. So these are other dependencies which we prefer to use the Apple ones rather than ship our own bundled inside that framework. So we'll go and add libstandard C++, the security framework, and libz to our project. The new version of Xcode makes this pretty easy. I think it's also fairly easy on Xcode 3. So I'm clicking on build phases and link binary with libraries. So hit the plus button at the bottom, and it's easiest just to search for things. So security, add, and if you're clever, you can figure out how to do this without opening the window every time, but I'm not that clever. So let's get the libstandard, and sometimes this little triangle hides on you. So let's get this libstandard C++. There's a bunch of versions. I always just pick the plain one. Not sure what would happen if you picked the other ones. And we've got to add libz. So there we go. That should be all we need to do as far as satisfying dependencies. But we've got to do one more thing. And so, ordinarily, an ordinary library, you would be able to just link the framework against the project and you'd be done. But Couchbase Mobile also includes some asset files that need to be present on the device for it to run. And so this step copies those over to the application when you click Build. So we'll just copy this line off the web page. It's rsync. And if you didn't put it in a frameworks folder, then you'll want to change the source path a tiny bit. What we're doing is we're reaching down into that framework that we've copied in, and we are copying it to the target path. So I'll copy the script line. We don't need the comments. And I'll come back over to Xcode and add a build phase. So we have a new build phase, add run script, and here we just paste that line in, and we should be done in the build phases section of Xcode. So now we're all linked up, but if we were to hit play right now on the application, nothing would happen because we've still got to kick off our actual Couchbase service. So here we go. I'm gonna go put just a little bit of code into the application delegate header file. If you're not familiar with iOS, if this is one of the first times that you've dug this deep into it, the AppDelegate is one of the first things that gets called on app launch, and so this is where we also want to start our server. So I'm going to drop this import line in here, and this should just automatically find the header file that happens to live down in the framework. And now all we've got to do is declare that we are a Couchbase delegate. So we type Couchbase delegate here in the angle brackets, and we're done in the header file. Now if we pop over to the implementation file, we'll need to add a little bit of code here to get to Hello World, and then we'll be ready to see whether I followed these instructions correctly. So I'm going to come back over to the web page and pull out these 3 lines of code and go back over to Xcode. Another little, welcome to iOS programming for new folks. This first method here, application did finish launching with options, is what happens. That's what gets called when your app is ready to go. So this is the place where you'd want to trigger any kind of service or background thread, or establish any global objects that your application is going to be referencing. So this is where the code will go. I'll paste it in because I'm less likely to make mistakes, but then I'll go over it line by line and say what it's doing. So this first line here, Couchbase mobile alloc init. This is just your standard give us an instance of the class. So CB here is our Couchbase instance now. All we've got to do is assign ourselves as the delegate and then call start. And the start method will rarely have an error. Usually if there's an error, it'll be an asynchronous error, and I'll show you how those are handled in a little while. But just in case there was one, we've wrapped it in this assert. So for folks not familiar with iOS, the delegate pattern here is somewhat similar to the way that this did finish launching with options method is called. What we're doing is we're telling the Couchbase instance that this class we're in now, the HelloAppDelegate, is the class that it should notify after Couch has started or if there are errors. So let's go pick up this notification code. I'll copy and paste it and then go over it a little at a time. So what we're doing here is pasting that in. So there's 2 methods here. The first one is the success case, and the second is the error case. The success case, Couchbase Mobile did start, passes you an NSURL, which is the server URL. And so what we're going to do in Hello World is just log this. In a real application, what you would do is hand the server URL over to either Couch Cocoa or another wrapper library, and then reference that throughout your application. And the reason you can't hard code the server URL is because conceivably multiple applications could embed Couch in them, so the server is launched on a random port, and that prevents there being any conflicts between application instances. So you've got to have the server URL or else you won't know how to access the Couch. But then once you have it, you can access it via any way you're comfortable with. You could point a web view at it, or you could start interacting with it with various REST calls from within Cocoa. And Couch Cocoa is a library that we've created and support for using Couch, but I won't get into it into this screencast because I think it's just a little out of scope for the hello world. So the second one is the error callback, and hopefully this never happens, but if it does, you'll want to log, why did it fail to start? And in our case, we've wrapped it again in an NS assert that's guaranteed to fail. So if this were to happen, the application would shut down. But if you wanted to handle the error in another way, for instance, you could fall back to a cloud-based URL and then just deal with higher latencies, but none of your application logic would need to change. So you have the option to do those things in here. So now I think we've got to the end of these instructions. Last time I did this, it worked. So we'll see how the demo gods are treating us today. I'm going to do iPhone simulator. Device should work. iPad simulator should work. You don't need 5.0. It should work on the 4.0 simulators as well. And I'm only doing the iPhone one because it'll take up less screen real estate. So we'll build it, and it should compile pretty quickly because most everything is already compiled in the static library. And we'll pop over here and pull up the debug logging so you can see what's going on. Here's the simulator. The app we created doesn't have any UI, so it's just going to be this white screen. And what we've got now is a little log message. Remember, we put into our app, Couchbase is ready, and we log the server URL. So if you want to double check that this really works, you can go back over to your browser and paste that URL in, and you should see the welcome response. I'll pull that over a little so you can see it. So this is your CouchDB API, like you're familiar with, from all these years, and it's got databases, and we can see that it ships in admin party. You don't need to be following this stuff if you're not a Couch expert, but if you are familiar with Couch, this should make you feel right at home. So that's Hello World on iOS. There's all kinds of ways you can get from here to a real application, as I mentioned, and maybe one of the easiest is to put a web view up in your app and point it to a URL in the server. You could upload an attachment, and that's where your application would launch from. But we'll come back to those in another tutorial or webcast, so we talk about actually building applications. So I hope folks were able to follow. I'm going to turn off my screen share now for a second and look to see if we've got Q&A that's come up. But again, if you're on our webpage here, and I went a little too fast for you or anything, this video should be all you need to see what I just did again. There's a link to the Couch Cocoa client library here, and some example applications, documentation. The community has a mailing list, web forums, anything you'd need to get in touch with us. So that's iOS for you, and let's see about the questions.
So yeah, Annie asked, does the whole database get replicated to each device? That is, so CouchDB, as Chris was talking about earlier, it's kind of a framework for being able to do sync, so it doesn't dictate what type of synchronization your application has. So you're able to, the common way to do this is provide a replication filter which is just a function that would say, I only want a certain subset of these items to get replicated to the device, so I can only keep active items stored locally and have a full backup on the cloud or your backup server. You can also have a replication that only works on certain documents as well, providing the doc IDs.
So an interesting pattern you can do, we see people do this, is replicate a minimum set of your data down to the device, just enough to kick off your application. And then as users are browsing around the app, or maybe it's location-based, you can do filtered replication to, for instance, pull in all the apartment listings within a 20-mile radius of where they're standing now, and then they'll have zero latency access to those apartment listings once they've been replicated down. So you've got a whole lot of flexibility, but by default, Couch is going to try and make all the databases be the same. So it's those filters that allow you to do subsets. There's a question about security here, and there are various options as far as the way the user authenticates with the server. The most basic way is, in the question, they've listed basic auth. You could use a basic auth style URL, name, password at server URL. But now you've got the password floating around on your mobile devices that are out in the field. And so what you'll probably want to do is use the built-in support we have for OAuth. So what you can do is establish some OAuth credentials on each device that correspond to the particular user, if you care at that level, or to some level of access. And then when the Couchbase mobile that's running on the device synchronizes with the cloud, it'll use those OAuth credentials, and it'll get the level of access the cloud grants to those credentials. And so, you've got two connections with different levels of authentication. Your actual connection between your Cocoa code and the embedded Couchbase mobile server can be, fully open, where that user has 100% privileges, and if they wanted to mess up their experience, they could go delete things and all that. Ordinarily, I don't try to worry too much about the user experience for hackers. But what you care about is the integrity of your data in the cloud. And so if you then put the security constraints on the cloud synchronization endpoint, anyone who goes and messes up their device database at the edge isn't going to hurt the users on their other devices. There's a question about how to sign up for CouchConf on October 24th. That web page that I went to, it is couchbase.com/couchconf-NYC, or you can get a link to it, I think, from couchbase.com. And it's just Eventbrite registration at the bottom of the page. It's $75 for the full-day event, and there's an after party. You might end up drinking more than $75 worth of alcohol there, so I'd say it's a bargain. A question about Phonegap, and there is not yet an official Phonegap Couchbase integration, but there's a whole bunch of folks who've kind of gotten started down that path. And I know Dale's done it a few times on Android. Dale, do you want to tell us what you've done on Android for Phonegap style?
Yeah, I mean, Phonegap's fairly easy to integrate, so it's literally just drop in a few libraries and instantiate the proper web UI. There are two types of libraries, CouchDB and Phonegap, that work really well together. So there's a concept called Couch Apps, which is the ability to serve full HTML applications out of CouchDB. And when you add Phonegap to that, you can have access to the accelerometer and photos, access the device file system, things like that. So there's no kind of standard reference implementation, but it's a fairly easy thing to do if you just follow the instructions on the Phonegap website, and there will definitely be a lot of examples coming out fairly soon. So
let's see, there's a couple questions. Using CouchDB with Bitcoin, I guess it would work. Couch is a database. Store some stuff in it. But more seriously, I think there are people who are hacking around with Couch's Bitcoin distribution. Essentially, with synchronization and the way that it's real time, you can think of Couch as a reliable message queue. Messages go in one end and they come out the other end for sure. So it works great for sending stuff around, Bitcoin stuff. Sounds like fun. And then on the does it drain batteries question, the answer is it's fairly decent on the battery. So the implementation uses an event-based architecture, which means that when it's idle, it's not consuming any resources. Of course, if you're doing continuous synchronization and you have events, and the event tends to be spaced out like once every 10 seconds-ish, that's going to be your worst-case scenario because your radio is going to be, popping in and out of high power mode the whole time. And what you'd rather do and this is, again, something you can tackle at the user level, is to schedule synchronization for maybe once a minute or once every couple of minutes. And this really depends on the application. Maybe when it's in the foreground, you do the continuous stuff and just eat the radio battery cost. And when it's in the background, you'll do something that's a little more efficient. So I want to make sure Dale has time to show us Android. So let's switch the screen over to Dale.
Cool. Okay, that's my screen up and going. So yeah, I'm just going to do a quick hello world for the Android, similar to what Christus did on iOS. Similarly, to develop an Android, you're pretty much required to have at least the Android SDK and Eclipse installed. So I'll be going through this assuming that you've got both of those installed. And same as iOS, it's on the couchbase.org website. You can navigate to Couchbase Mobile for Android. And the instructions to get started, the instructions that I'll be following are on that website. And there's a link on the right-hand side. This is relatively outdated, so if you follow either of us on Twitter, you'll be updated reasonably soon of when we'll upload the latest package. So I'll be working on the new version of the package that we'll be uploading shortly. So if you jump into Eclipse here, I will create a new project. It's an Android project, and then I'll just I'll call it Webcast. Currently on Android, the minimum target that we're looking to support is 2.1 for now. So I'd suggest picking API level 7 Android 2.1, and we'll just call Dale.webcast. This is just providing the ID for your application. Oh, sorry, you can't quite see the whole thing on screen. And the rest of the things you can just leave as the defaults. So that's given us a new project with the standard Android layout. And here is this is Android Couchbase.zip, and this is what you'd be downloading if you're looking at the website. So you'd usually pick this up from your downloads directory. It's relatively simple. You just unzip that zip file. There is a README that has the same instructions that are on the website, and there's two files, couchbase.zip and couchbase.xml. Now these files, you just need to drag them into your project and make sure you copy the files across, and you can see them appear there. These are the XML file is the build instructions just to tell where to put the certain files inside your project. And the couchbase.zip file contains all the assets for CouchDB. So you can do all this at the command line, but I'll do it through Eclipse right now. The easiest way is just to right-click on the couchbase.xml file and click Run As and Build. And you can see through there, through the log, that's just going through modifies your Android.manifest manifest to make sure that you've got the correct permissions. It copies the assets into the correct directory. This is a slight gotcha with Eclipse programming, is that when the files are modified, you'll have to remember to right-click the project and click refresh. Otherwise, Eclipse won't be able to see your new files. And you can see inside there, we've got an assets directory. This is where most of Couch gets installed, so there's lib, and there's all the source files inside your project. So going back to the website, you can see that now we're ready to, and these are the instructions that I just followed. It's relatively simple. Now we're ready to kick off an instance of CouchDB. So we'll just start copying and pasting some of this code over. The project for iOS and Android, we've tried to make sure that they're relatively similar. So the install process and the start process just works as it should. When you copy across that, of course, the code needs to be imported. That Eclipse will do it for you automatically. Back to Firefox. And I'll just copy and paste this code over one at a time. And I'll explain what this code does in a second. Right, so that's all the code that you need to get started with CouchDB. I've named this wrongly here, so this is going to be called AppDelegate. And that's just the name that's been up here. So the Couchbase delegate is just the callback interface to how we start Couch. When CouchDB starts, when your Android application starts, it's going to be into the onCreate function. So in here, we just call start Couchbase, which is the simplest thing. You generally want to wrap this in functionality that has your application, bootstraps your entire application, and starts Couch. In this, we just call Couchbase Mobile. We give it the context of the current application, and we give it the delegate, which is where CouchDB will notify your application once that it's started, and possibly that it's exited, which, as Chris said, hopefully that never happens. When Couchbase is started, it will do the Couchbase started callback, which will give you the parameters, which are just the host and the port. So you can see where CouchDB is running, and that's where you start accessing CouchDB. The same as on iOS, because there could be multiple applications running at the same time. We start on a random port by default, but that's another thing that you can override. So I'll start this. Oh, I've got an error. No, I don't. And then see how the demo gods are filling me now. Run as an Android application. So this is running on the Android simulator, and I'll bring up the ADB, which is the logs. So you can see now the activity started. We didn't make any changes to that, so that's another just blank screen that says hello world. Currently, you can see that CouchDB hasn't started yet, and this is the logs coming up. And yeah, Apache CouchDB is started on the public interface, which means that anybody can access it over the network, and on port 34108. So I will copy and paste that. And similar to Chris, just show that ADB forward, if you're not used to Android programming, is a really useful tool that will just, because on iOS, the emulator connects to local ports. So 5985 on iOS emulator is 5985 on your computer. But Android runs within a fully emulated environment. So you need to port forward anything when you want to access the data on the Android device. And I'll just do the curl 5985. And you get back CouchDB welcome, and that's the version that we're currently running. So that's how to get up and running. And as you said, there's also, similar to the Couch Cocoa library, we're developing Xtorp, which is probably the main Java library used for CouchDB interface. It's another driver library that allows you lower level access, so you don't have to formulate HTTP request yourself. And that will be pushed out at some time soon, I believe. I'll hand it over to Chris to talk about if there's anything else that should be mentioned first.
Yeah, I think that's a good, there's nothing that really stands out except for we've made a ton of progress lately on the boot time and the install time on Android. So it used to be that when you first installed it, it had to do a whole bunch of housekeeping work and copy a bunch of junk around before it was ready. We've eliminated the vast majority of that. So now, and also, that means less copies of some of those files on your device. So the install is both smaller and faster. And then the secondary boot is also a little bit faster due to those changes. How fast is it? I think, Dale, you're more in tune with, like on a real device on something. How long does it usually start, like both for first launch and second launch?
Yeah, I should have mentioned that during the screencast. The emulator is incredibly slow, so when you've seen that must have took around 15 seconds. On a real device, it depends on device per device. I've got an XSS and a HTC Desire here for testing. And the first install is generally around 10 seconds or so, sometimes less. And the second boot time is significantly less, and that's generally been around 4 to 5 seconds for me. There's a few questions I wanted to go over. For the SD card, by default, it will use the SD card for storing the database, because on Android devices, especially I've got HTC Desire here, that's only got 150 megabytes of flash RAM, so there's not much that can be stored on that. And that memory is used by applications, and if you use it up, you can't install applications. So by default, we do run on store the data files on the SD card. It's not a requirement, and I'll quickly show the layout of another project, Mobile Futon, which you can download from the App Store, and that's just a UI. If you're familiar with Couch, it has a HTTP-based UI, and I've built one that works for mobile. And in here, you can have your own ini file, which you can tell it what port to run on, tell it where to store its data. All that stuff's configurable by you.
All right. Thanks, Dale. So there's some more questions I see in the Q&A.
Yep.
This one looks like it might be a good one for you, Dale. What is the name of the Java library?
Oh, yeah. The library is Xtorp, which is, I'm not familiar with who originally developed it. Do you know, Chris?
Xtorp.org is the website for it. Henrik is his first name, and he's so it's a guy who wrote this for server-side Couch, and then we have been working with him to, there's some things about some of the standard library classes that are shipped with Android that we need to do a few little changes to support. And so there is, and it's working its way back into mainstream Xtorp, some Android Xtorp packages that you'll want to include also when you use it. And we'll have tutorials that go through that whole full stack application, in a matter of weeks. Right now, iOS in terms of documentation is maybe 3 or 4 weeks ahead of Android, and it's about to get some of those tutorial steps. So Android's next on the list.
Yep, and as sorry, I can see another question here. Is can you talk to CouchDB from a service? The answer is yes, definitely. Originally, we built CouchDB as a service on your Android, inside your Android application, so that it started using the start service callbacks. We changed that as it didn't allow us to do the in-process changes that we'd like to, but you can certainly still very easily go back and look at the old code and still build a service on top of CouchDB or have another service interact with it. And one of the APIs that we don't have in there right now, but we've had some requests for, is to make that delegate that Dale showed optional, and instead you could use intents. And so we'll have that out in time for the Android beta release and maybe even for the developer preview that we'll be pushing up next week. Here's a question from Chetan. It is, how is the synchronization performance while transferring the binary data? And it's a good question because large binary blobs are a challenge to deal with. The replicator is very robust in the sense that if something goes wrong, if you get disconnected, if it crashes, and you restart it, it'll pick up where it left off. And so that means that even on a very unreliable connection or with a crashy device, you can make progress if you just keep triggering that replication. But there's a caveat that if you have a binary file that's so big that it can't get transferred before a crash happens, like let's say you're trying to transfer 20 gigabytes and you can't find a network connection that'll stay open long enough to finish that. Couch doesn't currently have the logic. It'll retry from the beginning each time. It's a known issue, and eventually we'll have support for picking up those large transfers in the middle without having to start over. But right now, there's a practical limitation on the largest binary blobs that you can manage for synchronization of mobile devices, and it's basically a time limitation. Can you transfer that whole thing before the user gets bored and quits or whatever? There's another question. What about support for Adobe Air? And we're looking at that. It shouldn't really take any. Well, there's two sides of that. There is you're writing your Air application and you're going to interact with Couch, and so for that you could use any Couch and just code a URL to a remote server. But if you want the Couch embedded in there, I believe there are some capabilities that Air exposes that will allow us to provide an easy way to use Couch. We're not quite there yet, but we hear people asking for that, and so that's on our radar. And it may be higher on the list than some the other competing questions are like BlackBerry OS or Windows Phone, and so we're kind of looking at all that right now. Grant asks, how should you handle app shutdown, memory warnings, and multitasking? So currently today, when your app goes into sleep mode on iOS, the operating system takes away all your sockets, and any open connections you had are forcibly revoked. And there's nothing really we can do about that, but what we do is detect when that's happened, and when the app comes out of sleep, we restart the server so that it can become available again. And we bring it back up on the same port it was on before, if possible. So that's all enabled by default, and it'll just happen automatically for you. But if you need finer-grained control, what you could do is test after it comes out of sleep, is the Couch still available? And then if it's not, trigger the restart. So if you look at the header file, the Couchbase mobile.h header file, there's an auto restart Boolean parameter and a restart method that you can call on it. There's another question about what our Couch app actively supporting right now, and that's one of the reasons that we one of the reasons especially that I love the CouchDB installs for both iOS and Android is that they are fully fledged CouchDB servers. They have pretty much the entire functionality, minus the stuff that sometimes doesn't make sense. So you can do any Couch app that you do with a server CouchDB instance you can do with your device instance. So the app that's on the market, the mobile futon one that I talked about, that's just a Couch app. And there's a lot of Couch apps which I've just replicated to my device, and they're suddenly available on my phone, and there's nothing that needs to change apart from quite often their UI needs to be adapted for the mobile environment.
And yeah, we love all the different, I mean, you know, a long time ago, I was one of the first people writing Couch apps, but what I really am happy about that I've seen in the last few years is a big diversity in the way that you can do that. Because at the end of the day, it's just a tool that helps you get your HTML and JavaScript and stuff served out of Couch as a web server. So there's Canso, there's a few different Node.js options, there's the version written in Python, there's Erlang, Couch app toolkits, there's Eclipse plugins, all kinds of ways of getting it done, and they all work with, you know, Couchbase mobile or server. Oh yeah, go ahead, Dale. This looks like one for you.
All right, which one?
The content provider. Do you have a content provider wrapper around CouchDB for Android?
Oh, no. This would probably be one for Martin, but because I'm not entirely familiar with the content provider API. I know that both Aaron and especially on iOS, we're both looking at providing the standard data access APIs. I forgot what the one's called for iOS, backed by CouchDB, but I don't believe we've got any in the foreground working yet.
Yeah, that raises a good point on iOS. We had originally thought, hey, we're going to figure out how to hook this into the back end of core data so you don't have to change your apps at all for core data. But there's some issues about core data, wants to do everything synchronously instead of providing callbacks and asynchronously. And then also, once Couch Cocoa got written, we were looking at apps that, kind of converting them from core data to Couch Cocoa, and they were getting simpler. So we decided to stick with that for the time being. But we will, in the long run, I'm sure there will be support for Couch as a backing store for core data.
There's how safe is it to read-write from different threads in Android? And the short answer is yes, but I will leave it to Chris if he wants to explain the exact reasons why.
Well, yeah, I mean, the big reason why at the end of the day is that the underlying technology comes from a server that's designed to be able to service, thousands of users at the same time. So Couch has been built for the ground up to handle concurrent requests, and the only issue could be if you had a HTTP client that was not thread safe, and in which case, maybe you can instantiate two of them. I'm not really sure about the HTTP client ecosystem on Android, but the server itself can handle as many connections as you can throw at it. There's a question about what is the query performance rate for a 2 gigabyte database. I'm not sure about what happens once you get it up to 2 gigabytes, but generally on the server, until you get to measuring things in terabytes, the size doesn't cause performance issues, or rather performance changes. On my iPhone 4, just sort of a informal benchmark I did, I was seeing a couple hundred docs per second write rate, so that should be more than enough to support your average user clicking around in an application. So I don't see any other questions coming in, and I think we're almost out of time. If you have any other questions, ask them real quick. Otherwise, I think we're about to wrap up.
Okay, there's a few quick ones. Is there a concept of indexes and views? And yes, as I said, it's exactly the same as the server-based CouchDB instance. You can do your own MapReduce, and you can even plug in external indexes. So Geo Couch is enabled on the Android version now and on the soon-to-be-released iOS version. So it has its own indexer. Another quick question, is there a limit to database size? At least I know on Android it's limited by wherever you decided to store your data files. So that you could store them on flash if you wanted to, and they'd be limited quite quickly. But on an SD card, I've got 32 gigs spare on mine. I haven't tried to fill it yet, but it should definitely work.
All right. Well, thanks everybody for listening. I hope this got you started and is what you were looking for. Please do give us feedback. I think there's a feedback URL. We hope to be doing more of these and maybe get deeper into both Xtorp and Couch Cocoa, as well as maybe some of the Couch App stuff. So yeah, it's been real fun to have a group of people learning about this stuff with us. Thanks for coming out.
Yeah, definitely. Thanks a lot for listening to us. And yeah, if you've got any more questions or feedback, I noticed in the chat earlier people were asking about IRC. So CouchDB on Freenode, or you can send me or Chris Twitter messages or emails. Thanks a lot, everybody.